Alright, we're going lesson 6.6 here, which is on function operations. A lot of similarities from some things we did first semester, only we're going to have the negative exponents and fraction exponents, that type of thing. The new part will be actually finding the composition of two functions. That'll be towards the tail end. And all that means is you're going to plug a function into another function. So let's start off doing a little review here, just reminding how to plug things in. When I find f of 4, that simply means plug in a 4 and evaluate. Follow your order of operations. Simplify as far down as you can get. Plug in 4, you should get negative 8. Gets a little trickier here with the next couple of having us plug in a polynomial versus just a number. So here I'm going to plug in 2x. So I've got parentheses, and you're plugging in 2x into those parentheses. Going to the order of operations, I do exponent first. 2x squared is actually 4x squared. 2 times 2, 4. X times x squared. And 10 times 2x is 20x. 2 times 4x squared is 8x squared. So I get 8x squared minus 20x. You don't need to factor that. Some people factoring during class. That's not necessary here. I didn't tell you to factor. You can just leave it as that binomial right there. Finally, you've got 2 parentheses something squared minus 10 times something. Here we're plugging in 3x minus 2. And hopefully by now you're starting to go, man, he's trying to get me with the square dance again. That's not going to happen. Binomial squared is first one squared, twice the product. 2 times 3 is 6, double is 12. Last one squared. We've got some distributing to do. Got to distribute twice. 2 times 9x squared is 18x squared. Negative 24x, positive 8. Distribute the negative 10, I get negative 30x. And careful here, I get plus 20. Negative times a negative is positive. Add like terms, nothing goes with the 18x squared. 24, negative 30 give me negative 54x. And then the 8 and 20 give me 28. That's how you plug a function into a function. And that's really what I did there is I did a composition, and that's what we're going to do towards the end, as I mentioned. Okay, let's get into it here. First, let's talk about finding the domain. Domain is going to be all real numbers to start with, but then you got to look for a couple of problems. The two problems are if you have a denominator, you can't get 0 there. So anytime you have a denominator, say, hey, is there anything that makes it equal 0? And then the other thing is you can't even root a negative. So if you've got a square root or a fourth root, any even root, you're going to have a problem. And you're going to have to adjust the domain from being all reals. So here, this one's got a denominator. This denominator cannot be 0. So I'm just going to write that. 3x minus 2 can't be 0. Solve that. Hit the x along, I get x can't be 2/3. So that's the only thing that caused a problem in this one. Because of the denominator, you got x can't be 2/3. So I would write a domain of all reals not equal to 2/3. Example B also has a denominator, and again, that denominator can't equal 0. One of two ways to solve this. You can either isolate the square and square root, or you could factor x squared minus 1. If I isolate the square, add the 1, but I got to realize now that I've square root, I got to put plus or minus. So it'd be easy to forget that you need both positive 1 and negative 1. If you put a negative 1 in for x, you'd end up with this. You'd end up with 1 over 0, and that's not good. Divide by 0, bad things happen. Okay? So that caused a problem along with 1. So I'd say my domain is all reals not equal to plus or minus 1. C doesn't have a denominator, but it has an even root. It's got a fourth root. I can't fourth root a negative. So when you have an even root, what I want you to do is take the inside of the root and say that the inside of the root has to be greater than or equal to 0. It can't be negative. So I solve that little two-step inequality, add 4, divide by 3, and I say, oh, look, x can be anything greater than or equal to 4/3. Can't be smaller than 4/3. If it's smaller than 4/3, I'm going to be trying to fourth root a negative, which doesn't work. So domain, all reals, greater than or equal to 4/3. Last one's got both. It's got an even root and it has a denominator. So I'm going to do two parts here. I'm going to say this top part, the inside part here, inside the root, has to be greater than or equal to 0. So based on the top, x has to be greater than or equal to -1. Well, if you left it at that, 3 would be a possible answer. And if you plugged in 3, you'd end up with the square root of 4/0. And you're going, wait a minute, 3 can't work because I'm dividing by 0. So that's where this second part comes in. You go, wait a minute, this denominator can't be 0. So x can't be 3. So there's two parts to our domain. I'm going to say is all reals greater than or equal to -1, except 3. So anything greater than or equal to -1 would work except for that number 3. So that's how I would have to rewrite that domain. Okay, moving on. All right, here we're going to do some adding, subtracting, and then come up with a domain. I will mention that when you are either adding, subtracting, or multiplying two functions, the domain's the same. So if you've got the same two functions and I tell you to add them, subtract, or multiply them, you better have the exact same answer for domain. So A, here's all we got going here. We're going to add the two functions. This is actually no different than -2x plus 3x, which I'm confident you know is x. So what is x in this problem? It's not x, it's actually x to the 1/2. You could say 1x to the 1/2, but all you have to do is add the -2 and 3. Well, they turn into 1. And the x to the 1/2 stays the same. What's the domain? Well, x to the 1/2 means square root x. So this really means this. And looking at the beginning, you should look at the beginning when you're determining domain. Look at the setup. Don't look at the final answer, because sometimes you lose responses that, well, sometimes it'll end up simplifying. You're thinking, hey, look, my domain is all reals, but really, if you go back to the beginning, it's not all reals. So I can't square root a negative. Our domain here is x, or all reals, greater than or equal to 0. Well, that domain all reals greater than or equal to 0 for adding tells me that it's going to be the exact same thing down here for subtracting and for multiplying. So domains are always going to be the same there. I just need to go ahead and do the operations that I'm given and get my different answers. So here I'm subtracting. I have -2 minus 3. I can still just put these together because x to the 1/2 are the same. That's -5x to the 1/2. Multiplying. Some people get hung up on thinking the -2 is connected to this x to the 1/2, the 3 is connected to the x to the 1/2. You can rearrange these by operation or by properties of multiplication. And if you do so, you can say, hey, -2 and 3 go together to get -6. And then these go together right here. X to the half times x to the half is x to the half plus half, which is 1. Now here's an example, as I was trying to say earlier. This looks like you could plug in any real number and work, because you could take -6 times anything and it's fine. But because there was square root at the beginning here, because this means -2 root x, you can't have a negative. So that's why the domain is still greater than or equal to 0. Okay, so division is a little bit different with the domain, because when you write division down, you write the problem down as a fraction, you're going to end up creating a denominator. So what you might notice is that now you've got this square root in the denominator, and when you have a denominator, if you remember, I'd say, hey, we can't have that equal to 0. So you'd have x to the 1/2 can't equal 0. 0 divided by 3 is 0. Then if you square both sides, you find out that x can't be 0. And you probably could tell that in your head that x couldn't be 0. Okay? So now the domain is no longer all reals greater than or equal to 0. It's just greater than 0. Because we lost the ability to put 0 in because of the denominator. Now what's the answer? Well, simply, these are the same thing. Where's there more? There's a tie, so they just cancel. So the answer is just -2/3. So what does this mean? It means if I tell you to plug in x is 100, you're going to get -2/3. If I tell you to plug in x is 99, you're going to get -2/3. If I tell you to plug in x is 2, you're going to get -2/3. If I tell you to plug in x is 0, you get undefined, because it can't be 0. If I tell you to plug in any negative number, you get undefined, because it can't be any negative. So here, the answer looks like no matter what, it's always -2/3, but you got to go back to the beginning and say, well, wait a minute, we really couldn't put 0 or negative in there. Okay, one thing that I haven't mentioned yet, and I think I'll go back and do that now, is in your book, they have it written differently. So you might want to go back and say, this is the same as f plus g of x. They're written differently. You know, it's two different people that want to write it differently, and then the book just says, you know, you might see it one way, you might see another. They mean the same thing. So when you see these things in your book, it doesn't mean take f minus g and then multiply by x. It means exactly what we did. No matter how I write it, the way I had it on your notes or the way I'm writing it now, you get the exact same answer. Okay, so this is exactly the same as that. So keep that in mind. All right, here when you're subtracting, my point on this one is make sure when you're subtracting or adding or multiplying functions that you put them in parentheses. Because here what will happen is you'll forget that you've got to distribute the negative. And then add like terms. So I got x squared minus 2x squared is negative x squared. Negative 3x and negative 5x, negative 8x, and then you got a plus 1 at the end. My follow-up example, you could go ahead and reverse them, use parentheses, distribute, and get your answer. Or you could realize that g of x minus f of x is just the opposite of f of x minus g of x. If I tell you to do 8 minus 2, that's the opposite of 2 minus 8. So when you switch the order of subtracting, all you're doing is getting an opposite. So what's the opposite of this? That would be positive x squared, positive 8x minus 1. If you want to plug it in to verify, go ahead, but I'd rather you understand that. Oh, when you switch around, you just get the opposite. Okay, then the last thing in this 6-6 chapter is finding a composition. And here's two ways to write it. They mean the same thing. They're both read the same. It's read f of g of x. F of g of x. That's how you'd read it. And all we're going to do is plug in one into the other. When you have g of x inside, that means you're going to take the g of x and plug it in for x in the f. Okay? And again, the other way to write this would be f of g, and then of x means the same thing. So here's what I do. I say, all right, f is on the outside. So I'm going to take the f function, and I'm going to write it down, except I don't want the x in there. What I'm going to do is take the x out and replace it with parentheses. So instead of saying 2x to the negative first, I'll say 2 parentheses to the negative first. Now I take the g function that was to the right or on the inside and simply plug it in here. And look to simplify. To simplify this one, I would say it's got a negative 1 and an exponent. That's bad. So all we do is drop down the x squared minus 1. Leave the 2 there because that didn't have a negative exponent. And then we're good to go. If we want to talk domain on this one, I don't think I asked for it, but domain, we did one of this just like this earlier. Domain, again, would be all reals not equal to plus or minus 1 because the denominator can't equal 0. If you solve that, you get plus or minus 1. G of f of x is the other way around. You take the g function and plug it into the, or you take the f function and plug it into the g function. So I'm going to start by writing the g function first. Only I'm going to take the x out. And I'll put parentheses in its place. So the g function was x squared minus 1. So I'm going to write parentheses squared minus 1. Then I'm going to take the f function and plug that in. And we're going to simplify. A variety of ways to simplify this. I think I'm going to distribute the 2. 2 squared is 4. X to the negative second, because you do negative 1 times 2, minus 1. We don't like this x to the negative second right here, so what I do is just drop that below the 4, so it's 4 over x squared, and then the minus 1 goes at the end. That's simplified. Notice there's an x squared in the denominator, so x can't be 0 in the domain, so if I was going to write the domain, I'd say all reals not equal to 0. Moving on. C says f of x. F of x. That means we're going to plug f into itself. Well, f was 2x to the negative 1. So I'm going to go 2 parentheses the negative 1. And then I'm just going to take the f of x and plug it in. I'm going to go with, there's again a variety of ways to do this, but I'm going to go ahead and distribute this. So turn it into 2 to the negative 1 and x to the first. 2 times 2 to the negative 1 is 2 times a half, because 2 to the negative 1 is a half. And 2 times a half is 1. So our answer is x. And if you look at the end for domain, you might be thinking, well, it can be all reals. I can plug in anything on the end here, right here for x, and I get real answer. But you got to go back to the beginning, and this initial setup is basically 2 over x. 2x to the negative 1 is 2 over x. So x can't be 0. Okay, so even though it looks like x can be 0 on the right, it can't be 0 over here. So if we're asked, if I was asked for a domain, you'd say all reals not equal to 0. Okay, finally, we're going to finish it up with something that looks a little bit different, but it's just along the same lines. We're going to find g of 5. 2 ways to do it. G of 5. You can plug the g function into the g function. So the g function was x squared minus 1. So we'll go parentheses squared minus 1. And then we'll plug in x squared minus 1. And then we're going to simplify. We're going to do the squared answer right here. That'll give me x to the 4th minus 2x squared plus 1. And there's a minus 1 at the end. So I'd have x to the 4th minus 2x squared. So that's g of g. So that's the first thing you do. You write yourself a note. Find g of g. Then all you're going to do is plug in x equals 5. So take these x's right here and plug in a 5. That'll give me 625 minus 50, 575. That's one way to get it. The other way to get it is to just simply take 5 and plug it into G. So my G is x squared minus 1, so I'm going to plug in 5. That gives me 24. 25 minus 1 is 24. And then plug that answer into, well, it's a G again. So I'm going to take 24, plug that in for x, right here, and evaluate that. That'd give me 576 minus 1, which is 575, just like we got here. So two ways to do it. You can find the composition first. That's what we did here. Then plug in the 5. Or you could plug in the 5 to the thing on the left of it, the function on the left, and then take that answer and plug it into the function on the left of that. So your choice. So as we finish up with E, it would be your choice. I'd say go ahead and try this right now. Put it on pause, see if you can get it. Okay, let's see if you got it. Two ways to do it. How would I do it? Well, I would actually find the composition. And by finding the composition, I mean what's f of g of x. And if you look back up here, f of g of x we already found. It's 2 over x squared minus 1. So since we already went through the work of finding 2 over x squared minus 1, that's f of g of x. Simply plug a 2 into that. Put a 2 in for x, and you get 2/3. Otherwise, you could have taken 2, plug it into the g function. G function was x squared minus 1. So if you plug in a 2, you get 3. Then take a 3 and plug it into the f function. And the f function was 2x to the negative first, and if you put a 3 in there, you get 2/3 that way. So up to you. But since we'd already found the function, I figured, we're good. Let's use it. That concludes the lesson. Kind of another long one here. We spent 2 days in class. Thanks for watching. Have a great day.